Assalamualaikum and hello everyone. Today, our group will be presenting a topic from calculus, which is differentiation. Differentiation is a mathematical method that helps us determine how a value changes. It is one of the fundamental concepts in calculus and is widely used in many fields such as engineering, science, business, and technology. Now, let's begin by understanding what differentiation actually means. Before we continue, these are our group members. The first one is me, Haziq Iskandar bin Samsuri. Second one is Amirul Hakimi bin Hairul Nizam. The third one is Amza Ifan bin Hasnur Hisham. And the last one is Anas Riyadz bin Rohimi. Now, what is differentiation? Differentiation is the process of finding the derivative of a function. It measures how a function changes with respect to its variable and determines the slope of the tangent line at any point of the curve. There are many techniques of differentiation. I will explain it one by one. So the first one is chain rule. Chain rule is the basic differentiation rule used for function in the form x power of n, which is a number. Next, power rule. Power rule used to differentiate a composite function where one function is inside another function. Next, quotient rule. Quotient rule used when a function is expressed as one function divided by another function. Next, product rule. Product rule used when a function is the product of two functions. Next, constant rule. Constant rule states that the derivatives of a constant is zero because a constant value does not change. Next, exponential rule. Exponential rule used to differentiate exponential functions where the variable appears in the exponent. Next, logarithm rule. Logarithm rule is used to differentiate logarithm function, which is shown in the picture. Next, trigonometric rule. Trigonometric rule is used to differentiate trigonometric function such as sine, cosine, and tangent. And the last one is generalized power rule. Generalized power rules extends the power rule to function inside bracket, which is chain rule function. Those are the main techniques of differentiation. Understanding these rules is important because they help us solve different types of functions. Now, let's move on to some example questions to see how these rules are applied in actual calculations. I would like to pass the presentation to my groupmate.
Okay, now we are going to find the derivative dy over dx for the equation 5. Cosine x plus y negative 3 exponent power 2y equal 4x power of 2. Because y is embedded inside the cosine and exponential functions, we can easily isolate it. So we will use implicit differentiation, which means we will differentiate both sides with respect to x, applying the chain rule whenever we counter a y term. So now let's look at the left side first. For the first term, 5 cos x plus y, the derivative of cos is negative sine. By the chain rule, we also have to multiply by the derivative of the inside function x plus y. The derivative of x is 1 and the derivative of y is dy over dx. This gives us negative 5 sine x plus y multiply 1 plus dy over dx. For the second term, negative 3 exponent power 2y. The derivative of e power u is just e power of u. Again, by the chain rule, we multiply by the derivative of the exponent 2y, which is the 2 dy over dx. Multiplying the constants together gives us negative 6 exponent power 2y dy over dx. Now the right side, the derivative of 4x squared is straightforward using the power rule, 8x. Putting it all together, our equation becomes negative 5 sine x plus y, 1 plus dy over dx, negative 6 exponent power 2y dy over dx equals to 8x. So our next goal is to isolate dy over dx. First, we need to distribute the negative 5 sine x plus y into the parentheses. That gives us negative 5 sine x plus y, negative 5 sine x plus y, dy over dx, negative 6 exponent power 2y dy over dx equals to 8x. Now we want all the terms containing dy over dx on the left side by all other terms on the right side. We'll move to the non-dy over dx term. Negative 5 sine x plus y over the right by adding to both sides. Negative, so it becomes negative 5 sine x plus y dy over dx, negative 6 exponent power 2y dy over dx equal 8x plus 5 sine x plus y. Next, we factor out the common dy over dx from the left side of the equation. Dy over dx, negative 5 sine x plus y, negative 6 exponent power 2y equals to 8x plus 5 sine x plus y. To completely isolate dy over dx, we divide both sides by the expression inside the brackets. Dy over dx equal 8x plus 5 sine x plus y over negative 5 sine x plus y negative 6 exponent power 2y. Finally, to clean up the expression and make it look neat, we can factor a negative out of entire denominator. This gives us our final result dy over dx equal negative 8x plus 5 sine x plus y over 5 sine x plus y plus 6 exponent power 2y. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Amza F. Hashim. I am here to present my question, which is 3e, which is 5 cos open bracket x plus y close bracket minus 3e to the power of 2y equals to 4x times 2. How do I solve it? Is by breaking up the question into 3 terms. The first term, which is 5 cos open bracket x plus y close bracket, and that's the first term. For the second term, which is minus 3e to the power of 2y, and the third term is 4x times 4x to the power of 2. Starting with the right side, derivative if 4x squared is simple to 8x. That's straightforward. Moving on to the left side, which is the first term, which is 5 sine cosine of x plus y. We apply chain rule here. The outer function is cosine, which is derivative to negative sign. The inner function is x plus y, and its derivative which respects to x is 1 plus dy over dx. Because both x and y contribute, so this term becomes negative 5 sine of x plus y multiplied by quantity 1 plus dy over dx. Moving on to the second term, which is 3e to the power of 2y. Again, we apply chain rule over here. The exponential function derivative to itself, and we multiply by the derivative of the exponent to y with respect to x, which is 2 times dy over dx. So these terms become 6e to the power of 2y times dy over dx. Now we write out the full differentiated equation and expect the bracket we get, which is negative 5 sine of x plus y minus 5 sine of x plus y times dy over dx minus 6e to the power of 2y times dy over dx equals to 8. We then move them all terms containing dy over dx to one side and everything else to the other. After factoring dy over dx out of both terms on the left gives us dy over dx times bracket negative 5 sine of x plus y minus 6e to the power of 2y equals x 8 plus 8x plus 5 sine of x plus y. We can isolate dy over dx by dividing both sides by bracket. After the factoring, we get the final answer, which is dy over dx equals 8 plus 8x plus 5 sine of x plus y all over negative 5 sine of x plus y minus 6e to the power of 2y. And that's all for now for me. Thank you.
My name is Amirul Hakimi, and today I will presenting question 4e. So question 4e is a linear approximation question. So we can use two formula. This formula are actually the same, which is fx is approximately equals to fx naught plus f prime x naught times with x minus x naught. Or we can also use fx naught plus delta x is approximately equals to fx naught plus f prime x naught times delta x. We can use both of these formula because it is basically the same. Moving to question 4e, there are 3 over 2 plus 1.05 squared. And this question has a decimal. And to find the answer, the decimal is hard to calculate. So we change it to x. So fx equals to 3 over 2 plus x squared. Then we can find prime of the fx, which is f prime x. First, by lifting the denominator to the numerator and adding up the power of negative 1. Then we just simply differentiate this equation using chain rule, and we will get negative 3 times 2 plus x squared to the power of negative 2 times 2x. Then we just simplify all this, become negative 6x over 2 plus x squared squared. So next step is we must find x naught. So what is actually x naught? X naught is a number that are the nearest to x, but it is easier to find the solution because usually x naught are the whole number, meanwhile the x is decimal. So in this situation, x is 1.05. So we can just take the nearest whole number, which is 1. Next step is we must find the delta x. So what is delta x? Delta x is the difference between x or the change in x. So simply put, we just minus the x with the x naught. So 1.05 minus 1, we will get 0.05. So the step 4 is we can just calculate the linear approximation using the formula that been said before, which is fx is approximately equals to fx naught plus f prime x naught times delta x. Since we have find all these fx naught and f prime naught and delta x, we just can put all this together inside the formula. So we can substitute x and x naught, which is x equals to 1.05 and 1 x naught equals to 1. So it will become x over 2 plus 1.05 squared is approximately equal to 3 over 2 plus 1 squared plus negative 6 times 1 over in the bracket 2 plus 1 squared to the power of 2 and times with the 1.05 minus 1. So we can just we just calculate this out, which is 3 over 2 plus 1 squared is 3 over 3, and it just became 1. Next, negative 6 over 2 plus 1 squared, which is 3, and 3 squared is 9, and we just simplify it, will become negative 2 over 3, and it will be times with 0.05. So after negative 2 over 3 times with 0.05, it will become negative 1 over 30. And 1 plus 1 negative 1 over 30 will become 29 over 30. So we just change this into decimal, and we will get 3 over 2 plus 1.05 squared is approximately equals to 0.9667. That's all from me. Thank you.